So yeah, this is the intro to Fugato, a library that I worked on with some people at Vouch. We'll get into why that was useful, but I want to start with a quote because I think it's kind of applies to this. It's like testing in general. All happy code bases resemble one another, except the testing approach, which is unhappy in its own way. My feeling is that there are various methodologies, and we're all. I feel like I'm constantly looking for better ways to test. I feel like in many ways, like testing is a place where there could be significant improvements, and there's always often a struggle to, I think, be testing in a way that feels good. So what is Fugato? It's actually yet another Clojure stateful property-based testing library. We started on this actually quite some time ago. And at the time, like 3 years ago, there wasn't really a sort of a la carte thing. There were like some blog posts, people sort of cobbled things together. There wasn't anything that you could just use off the shelf. There have been, again, like there were sort of like touch and go efforts, but nothing like actively maintained. And most of them also, I think, were trying to more or less replicate like things that John Hughes and sort of the Cubic sort of quick check sort of papers sort of proposed. Like not just adopting the approach, but the sort of the interface. And we kind of diverged from that. But there are definitely other options now. I was at ClojureCon last year. Alan Runner, I think is his name. He created a library called Test Contract, which seems to have quite a few features, and it does quite a few of the things that I will talk about. And it may be better suited for some people. So there are options now. Fugato is probably unique in that it's just symbolic only. Again, if you look at Cubic's quick check, there's a lot of stuff around making it easy to execute, like to actually run your code. And Fugato, in sort of like a decision to make it sort of simpler and to make it, easier to integrate, we avoided that. And you'll see that it's really just about symbolic expression. And if you want to run it, you have to do a small amount of work. But that means that it's very easy to integrate in that there's no assumption about how you want to do that integration. Some caveats. I'm not even currently using Fugato at the moment, though I think there are many great use cases for a library like Fugato. But property-based testing requires there's a learning curve. It might be overkill for the work or a bad fit. At Vouch, the work we were doing there was a critical global property that we actually were having a hard time testing with unit tests, and we found it to be a huge help. So if you examine your system and you know that there are some global invariants that you're always testing in unit tests, but really your unit tests are only, testing a very sort of hard-coded flow, and you would like to have more coverage under more complicated scenarios that you're not going to write by hand, where it's becoming impractical to write them by hand. If your testing looks more like that, then maybe something like Fugato or Test Contract will be useful. Fugato, again, just to repeat, it just doesn't do very much. It's only symbolic. It just generates data. What you do with that data is completely up to you. But it makes it easy to have fun. In the code that I'm going to show, you can see that like you can basically like model a little game, and then when you ask it for the commands, it's very easy to read the commands, and you'll see that it's like, oh, it's a well-defined world, and this is able to generate operations on that world that makes sense. So I think it's very approachable. I feel like Fugato is very approachable. Maybe it's a good place to start when you're trying to assess whether stateful property-based testing would work for you, and then you can go choose maybe a library that has maybe more of the bells and whistles that you might want. But why Fugato? The reason we needed it originally was that we had typical unit tests. Vouch, what did Vouch do? Vouch was really a identity and asset management system with shareable digital keys, right? So that meant that we shipped a thing where you could had a vehicle and you have a key and you want to share that with family and friends. Or maybe you're a dealership on the lot and you want to share that with a potential customer. And, say you share a digital key with a friend. Well, maybe you want to allow that friend to share to another friend. So a transitive key share. And maybe you want to unshare the key, right? So there's just like all these scenarios that could occur. And we wanted to know, that the end state of a particular series of operations would make sense. And again, there was a certain point we could do the unit test, but for certain scenarios, it became clear that the handwritten coverage was never going to be great. Specifically for us, our system was built on top of a blockchain called Tendermint, and what we wanted to know specifically was that with the chain, that there was no code that we were going to write that was going to break the chain, meaning that you make some change and you inadvertently change the blockchain such that if you played all historical transactions, the sort of app hash, this hash that you compute that represents a particular state of the chain, would be different. So you make a change, and now your change is broken because you couldn't play back the historical transactions. So that's a pretty intense global property that you have to maintain on all commits. So Fugato was like a safety net for us. What we would actually do is we would generate like 30 or 40 scenarios with like 30 or 40 steps, which we'd never write by hand. And we could play those scenarios back, and we would have the historical hash that was computed for the state of the system after those commands. And anytime you would commit something, we would run those again to make sure that, again, we weren't breaking the historical computation for the hash. So just reiterating, innocuous changes could easily break the chain. It was just extremely easy to do, and Fugato gave us a way to check for that. Sure, there were probably other process improvements, but like a lot of teams, our team was very small, and so Fugato our approach was a way to get a lot of leverage with not that much effort on our part. We were able to basically, you push your commit, and you could see that you were going to break the chain in the PR. That was cool. So then, you might be asking, why symbolic only? Fugato, again, it doesn't do anything other than generate these sort of data structures that represent commands. It provides no helpers for testing your code. It just produces the commands and the arguments that go along with those particular commands. You build the model, we'll see this. We'll build the model for a very simple game. And then when you execute the model, you get commands out of it, and you get shrinking. We are able to check, for example, that you have a certain expectation, that expectation is violated, and then we can shrink the model to find the minimal set of commands that failed, some property that you were checking for. And that's, of course, necessary for actually being useful, because, in a lot of these situations, the state spaces can be quite large. When we started out, another thing to understand is that when we started out, we realized for our work, the model that we were going to make, it didn't really actually need to test. This is the other thing about doing stateful property-based testing, is that you might think that you want to test every API call or particular sequences of things. But what we discovered is that that we didn't want to test at that level. And by making it sort of symbolic, we started with the model and said, what are the sort of higher level abstract operations in which we think the system works, versus thinking about the specific methods that the running system actually has. And by doing this exercise, I thought we got a lot of the benefits one might get from doing sort of model checking. You have these TLA plus or whatever. You build a model and you check the model. But what's really nice is we were able to build the model at a high level of how we believed a correct system works. And then it was easy to both verify just by looking at it, but then also write a thing such that we could map this higher level thing to the calls that were necessary. But we weren't tied, since the commands that are being generated, we weren't hard coding any specific API calls. If the nature of those API calls changed, again, we were decoupled. So I definitely think there were some benefits to the symbolic only thing that we didn't want to give up after trying it that way. It also means that Fugato, it's like tiny. I'm not at Vouch anymore. I had a great time there, and this was one of the last things I did was to extract Fugato out from the code base, and it's only like I think it's 115 lines of code, so it's very tiny. And a lot of that's because it doesn't have any extra facilities. It really is something I feel like you could sit down, wrap your head around stateful property-based testing, and then make a decision whether like an approach like this where it's like it's like a very finely it's a very specific tool that's easy to integrate with your existing practice, or you want to go now that you understand the concept, you want to go out and find something that has more bells and whistles and maybe just a better fit for how you like to work. I think the main thing to understand is that test check is a bit of novelty if you're not familiar with it. And what it was for me, like until I set out to write the first version of Fugato, I wasn't really forced to understand how test check worked. I actually think that something like Fugato is a pretty good introduction to test check and how test check works. And we'll see that. You don't need to know that much about test check to be productive with Fugato. And just in general, I think it's easier to play with, and we'll see that. The example that I'm going to show is the one that's on, it's on the repo, but we'll walk through each bit, try to understand each bit, and I think it's kind of fun. And yeah, we're going to build a little sort of tiny little world that's kind of like a game. And, again, by having this tiny library, I think it's easier to build up intuition about the approach. So using Fugato, there's not much code there, and in fact, most of what you're doing when you're doing Fugato is building up a model of the system, like a toy model, right? You have your real system here, and then you have to sit down and sort of describe to yourself, well, what is the aspect of our real system that we're interested in representing, sort of in a data-oriented way. And again, it doesn't have to be every feature of your system. What is a model of a particular aspect of your system that you care about? In our case, it was almost entirely about like transfer of ownership of vehicles and the sharing of keys between actors, right? How does this asset move between different parties? And when people share that asset, are the permissions correct? And at the end, are we not going to affect the chain? Like that our code changes don't affect the behavior of the chain. So there were many features in our system, but we sort of focused on that part, right? There were many things we could do, but we decided, okay, transfer of ownership, sharing of keys, and then making sure that the app hash is not changing. So that's what we selected. And the way that we did it, you can have multiple models, right? You could make a big model, or you could say, well, we have actually various models for testing various different things. And the nice thing about restricting the model as well, the side benefit, which we decided, was that then the search space of the search space becomes reasonable, because one thing that you don't want to have is you don't want to have too many choices at each step. And then what happens is that maybe when you're generating commands, you're floundering in uninteresting spaces, right? You really want to have a search space that produces interesting scenarios. And again, that's why we sort of focused on not trying to model everything, because if we started doing that, maybe the search space, the area of the search is always leading towards very uninteresting things where things are going back and forth, but nothing that's actually testing our system is happening. Yeah. Again, to reiterate, why did we end up there? We tried to write unit tests, and the unit tests were just getting longer and longer and longer. The more users that were involved, the more assets that were involved, and there's a certain point where it's just not practical. The unit test is no longer, it's no longer readable, right? It's not easy to maintain because there are so many different things you have to keep track of in the unit test. It starts getting hundreds of lines long. I mean, where's the unit test? It's just like a big, complicated test. Yeah, and we had a lot of entities, so to speak, in any given test, right? We had to model users, We had to model the devices. Like the device is the thing that was being used to share the actual key. We had assets. We had transfers of ownership. We had key shares, but there were two kinds of key shares. And then we also had revocations. And these all were aspects of our system that had to appear in a unit test. And it was really just the combination of all these actions that made the unit test become unwieldy. Once you wanted to do something, fairly that wasn't trivial. The unit test was starting to get quite big. Yeah, and what would happen is that in fact we would get the customer would tell us, on a ticket, like a fairly concise description of the failure, but in terms of all the entities that were involved, it was, it wasn't actually as small as was written in the ticket. So yeah, that was the other thing, is that fairly concise descriptions as far as what was being said by the user involved, quite a few assets, and the setup for that scenario is not as simple as it appeared. Definitely early on, we definitely had, before we built the framework that later would be driven by our property-based testing, earlier in the process, it would actually take a long time. Reproducing this very concise description of the customer take a long time. And so that led us to doing the first step that allowed generative, so this stateful generative testing to work well, is first we built a purely functional scenario-based test where we could, in a functional way, describe the scenario. We were talking in a higher level way that, we had to lift our unit tests into a higher level of abstraction, and also make those unit tests purely functional. So before we built Fugato, the Fugato thing, we actually went ahead and built a purely functional model of our system, where we, you could basically write a unit test, but we had basically helper functions for describing user devices, assets, the datomic DB, the sparse Merkle tree, which represented the chain, and then we put everything into a map, right? So that was the other benefit, is that everything is sort of like in a map, and the tests themselves are purely functional. There are no, in the tests that we would write, there were no side effects. And just by building this model, we benefited from removing the boilerplate. And I actually had, in sort of the long view, by doing this work, that we would be able to drive it with property-based testing. So it was sort of like the earlier part of the work, so that we could, again, leverage property-based testing later. So yeah, we built the adapters so we could invoke most of the operations using the model state. Of course, this was our hook. We would be able to take the output of the commands that were generated, and then we could invoke, we could actually hook into these adapters that would drive the system. For our work, the work that we were doing, again, because it was so much oriented around the chain, we did have an HTTP layer that, of course, was actually being invoked, but we ignored this because we did test the HTTP layer separately, but it wasn't a part of the property-based test. It could have been, but again, we had to pick and choose given the amount of time that we had. By ignoring it, we really had a very nice REPL-friendly system. By the time that this sort of like model, sort of scenario-based system was built, we were able to take, a description and a ticket and write a unit test. Again, that was very high level in like 15, 30 minutes, sometimes less. And that was a huge win. Again, this whole time looking towards a future where it could be driven by something else, property-based testing. There are limitations with this approach. The scenario-based, not with Fugato, but the scenario-based tests, in that, even with all that work, there were some complex tests that were hard to write, where you might want to test something that involves 30 vehicles or 20 users or whatever. Many transfers, shares, and revokes, that just becomes unwieldy. But again, since we took the time to build the model, it became clear, right? We extracted the value we needed. We had better unit tests. They were easier to write. They were easier to convert from the tickets. But it was also, we reached that point where it's like, yes, we don't have to drive this ourselves. And that's really that moment once we had completed that work that we had started looking at stateful-based, property-based testing again. Again, this is historical. Now there are some options, but at the time, there wasn't, there weren't many options. And again, in our opinion, they did it too much because again, we didn't really need to do the work of calling things directly because we had already built this sort of layer around it. So we didn't need that feature. And that sort of, again, led us to, focus on the symbolic part. So what are the concepts you'll see, hopefully that from a high level, that gives you a picture of why we ended up there. And maybe hopefully gives you, for those of you that might be in working on something where you might also benefit from it, maybe it gives you some fodder for being like, oh, we have a similar problem. Maybe we can go this way as well. What are the concepts when you use Fugato? I mean, the very first thing is deciding on representing a state. And this is about building the model. We're now talking about Fugato. You decide on a state representation. And that state representation actually, it doesn't actually need to be your actual system, right? When you're building a model, the way that you represent the state doesn't actually need to be the real system. And we'll see that. Your real system can be representing state in a different way. When you build the model is this state that we're representing, the state representation is just so that we can produce commands, right? We're just creating a state that is used for us to decide what commands we should generate. So we are very much building, again, a toy version of our application. A model is just a map of specs. So when you make a model, it's really just a map of specs. The keys of the maps are the command names that are going to be, they're going to be a part of your model. The spec, right? The spec, so each key is the name of the command, and the spec for a command is just a few things. It's whether, can this command run right now? What are the arguments that are going to be generated when we create this command? What arguments go along with it? How do we compute the next state? Computing the next state is important because that will control what other commands could be generated. And then because of shrinking, we need one more thing, right? We need one more thing because what shrinking is going to do when we shrink, like say you have like 50 commands and there's a bug. Well, we want to find the smallest number of commands that recreates the bug. So what test check does under the hood is that it starts shrinking. Once you get to a property-based test failure, it tries to shrink the commands. And what's going to happen is that we will randomly evict the command. But if you randomly evict the command, maybe your commands are no longer valid, right? Because so valid's purpose is that maybe during shrinking, a particular command gets ejected, and maybe we're not valid anymore because some previous command that created a state that we need is no longer there. Therefore, we also need to be rejected. So this is pretty cool, though. This whole process actually speeds up shrinking, right? If some command in the middle is ejected, then as we're shrinking, we may throw out a bunch of things. So this actually helps shrinking move quicker, right? It's a way to say, these are the commands, and we're going to start shrinking. And as we randomly drop commands, we're able to rapidly shrink to the few commands that cause the failure. So just to reiterate, run is whether this command can run. Args are the arguments that we're going to generate with that command. Next state is a function that takes your model state, this simplified state that you created, add something to it such that the next command that will be generated can expect it to know whether it can run. And then finally, valid, which is that during shrinking, maybe a previous command gets rejected, and then maybe we need to get rejected. Valid will run that check. Honestly, everything but args requires only a basic understanding of Clojure, right? Run is only going to look at this simplified model, which might be a set or a map or whatever you decide to represent your state. Next state, you're literally going to take your simple value, state value, and add something or remove something. And then valid is also pretty easy because that just requires looking at the state and saying, well, I can't do the thing I wanted to do because the thing I needed was in the state, but it's not there anymore. Really, only args requires you to know about test string generators. And fortunately, for the most part, you don't need to have a complex understanding of it, but you do need to know how it works. And I think that Fugato has a pretty nice intro to that problem. We'll learn a bit about them. So let's go ahead and look at Fugato and see what that looks like. So hopefully everybody can see this. So here, this is in the Fugato repo. There's a test namespace where we're building up a model. Just to describe, it's a room. We have a room, 2 rooms, right? 2 rooms, and there's a door between them. There's 2 users. You can see here that in the beginning of the world, both users are going to be in the first room, and the key is in that room. Now, a user can pick up a key, unlock the door. If the door is unlocked, anybody can open that door. And if the door is open, anybody can move through it. And of course, anybody who has the key can drop the key. The door has, a lock state, unlock state, and open state. And we'll see all of these, or I guess a closed state as well. We'll see all these cases when we look at the predicates, because we have a bunch of helpers. But again, this state is not my actual game. This is the model state. This is I'm making a model of the world such that I can produce commands that are valid for that world. So again, this is not my actual game. This is a model of my game. So we have some helpers for being like, let's look at is the door locked? It looks at the door. Is it locked? Is the door closed? Is the door open? This is, I think, fairly simple stuff. We're just looking at the state, and we have some predicates. Is there some user who has the key? We look at the state. Does somebody have it? We want to get the user with the key. Like, we want to know which user is it? Who has the key? Which room is the key in? We want to know what, there's a helper, like we want to know if the user and the key in the same room. And then we want to know if we have a user, we want to know which room they're in. There's a predicate for being, is the door closed and the user has a key? Is the door locked and the user has a key? And again, these are just compositions of this. And we'll see in a moment, these are used by the run, like the run question mark, the valid question mark. And even in the case of arg generation, when we generate arguments for the command, we also need to use these predicates to know which arguments to produce. I'm going to skip just really quickly before we go through the specs to the actual model. So this is what I was saying, right? This is the model. Each one of these is the name of the command. And when we generate the commands, we'll see that. We'll be open door, and there'll be the user opens the door, closed door, and the user that closes the door. The argument being the user that did the action. Which user locked the door? Which user unlocked the door? Which user took the key? Which user dropped the key? And then which user moved and which room did they go to? So the model is a map of these command specs. So let's look at the open command spec. We can ignore this for now. It's not super important. There is like a frequency knob, like how often the command will be generated, but it's for the purposes of this talk, I want to skip that. Now, can we open the door? Like this is like, can we be generated? Can we generate this command? Well, we look at the state, and we can if the door is closed, right? You can open the door if the door is closed, not locked. Locked is different, right? If the door is closed, yes, you can open the door. Here we see our very first arg generation. So here we want to make a tuple, and here we're saying this tuple, right? Args is a vector, right? Or like a tuple. It's a tuple of arguments, right? In this case, it's just going to be a single thing. So here we're saying it's either user A or it's user B that's going to generate it. So here in gen, we're saying choose one of these 2 things, and then make from that single value, return a tuple. So it's going to be a tuple of either just user A or user B. Those are the arguments to opening the door. Closing the door is going to look the same because either user can close the door. Down here, before we move past this window, the next state, right? We take the state and then we set the door state as being open. And then this is for shrinking again, valid. For example, if the state was altered because of shrinking, we're only valid if the door is closed. If the door isn't still closed, right? We were generated when the door was closed. If the state of the door is no longer closed now, this command gets thrown out. The rest, close looks exactly the same, except for it alters the state of the door, and the condition for whether it's valid during shrinking is different. Locking is slightly more interesting. Can we run? The door has to be closed, and someone has to have the key, right? Some user has to have the key, and the door has to be closed. Here, now you see the utility of this helper. Here, only one user can have the key. So the arg generation here says, get the user with the key, return it, and put it in a tuple. So it's only possible for one user to have that and be in possession of the key. Now the door is locked. Is this command valid? And again, we're just checking, is the state such that the door is closed and the user has the key? Reiterating whether it's runnable. And in fact, I wrote this some time ago. I believe, no, right? Here we have the user because, see, look, invalid, you're given the command that was generated, right? Valid is about the command that was generated. That's why we're not reusing this function, right? Here, we're destructuring the command that was created, right? Here, we are producing the arguments of the command that will generate, and this is determining whether we can generate it. At valid, the command exists, and it's, you should use the command itself to figure out whether you're still valid. Okay, and then similarly with unlock, right? Unlock's going to look very similar to lock. Again, we're going to use the generated unlock command, the arguments that were provided to it, to determine if we're still valid. So this one is interesting. Here, take key. We have to know, in order to run, is the user and the key in the same room? Like, they have to be in the same room to even take the key. Here we get the room with the key, and then we remove the key. And the next state, the way we do this, again, this might not be the best way, but for the simple model, the user itself is a set, and then we add the key to the user. Going back up here to reiterate, see, the user is a set. We can put the key in there. User B is a set, the same way that the rooms are sets. We're just conjing as this item moves around. We're moving users between that, and we're moving the key around as well. Drop key is going to look very similar to taking the key, and moving is going to be a little bit different. So here we have a little helper to move between rooms. Let's talk about this one, because can we move between rooms? Whether we can generate this is easy. The door is open, right? Is the door open? This one's harder because we have to generate two. We have to generate two things, right? Previous, we only generated one argument, but here we're going to generate two. Which user is going to move? So we pick between A and B, and then we have to use bind, right? So this says choose one randomly, and then given the one that we chose, we use this to pick a room. So which room is the user in, and then we're going to choose the next one. And then we return the tuple, right? So this is because the first argument is going to make a difference on the second argument, right? User A should always move to a room that they're not in, and that's why we need to use bind. We're saying pick between these two. Once you pick one, pass it to us so that we can finally generate the argument tuple that we need. It is actually necessary. For example, you might be like, this seems like a lot of work, but actually when we start shrinking, it's possible for the test as it shrinks to actually swap these as well by doing it this way, because maybe it's something about these two, the arguments themselves. And then we have next state, which is going to be for moving. We're just going to take the user from the current room. We're going to update the room. So you're removing the user, adding a user, and finally, this is only allowed if there's an open door. If there's no longer an open door, we reject it. So that was a bit of a long. I know it was a bit of a long explanation, but I kind of wanted to be comprehensive. Now let's look at the commands. Like, let's see what happens when we actually generate the commands. So here, yeah, right, okay. Okay, so we're in this namespace now, and this namespace is the game. It's the actual game. This is no longer the model. This is the actual game. Of course, I chose the same representation here, but this could have been in the database. Like, I didn't have to do it this way. We could have represented the state however we wanted, but for brevity, it just shows that the model has its own state, which is totally separate from my game. This is the actual game, and the game does all these things, right? It actually takes the state, it actually alters it. It's not a model, it's the actual game. And as you can see, the game is shorter. The game is much shorter than the model. But hopefully it's clear that, like, in a real world system, that's almost never going to be true. The actual system is going to be way bigger than the model. It's very highly unusual for the model to be bigger than the actual system. But in this case, as you can see, there is, this model is trivial, therefore it's pretty small. But coming down here, let's take the model. So here we're saying we have the model from the other namespace. We have the world, which is just the initial state. And then we generate some commands. Oops. Let's do this. Let's get rid of this. This. Oh, sorry. Hold on. Sorry. Sorry about that. Okay. So let's scan over this and let's see if this makes sense. So user A takes the key, user A unlocks the door, user A locks the door. So this goes to, like, why it's important, why I think that managing the model can be important. And there are ways to control the nodes. We don't have time to get into that here. But the user unlocks the door. But here's where it gets interesting, right? User B opens the door. Now that the door is unlocked, user B opens the door. Then user A closes the door. And user A locks the door. User A unlocks the door. User A unlocks the door. Then drops the key, takes the key. So this is, I would say this one, not so interesting. So let's try it again. Yeah, it gets better when it's a move. So take the key, drop the key, unlock the door, open the door. Then A moves. And then A drops the key, right? So in order to pick up the key, you're going to have to be in room 2. User B closes the door, right? So nobody can move back. Then user A opens the door and then moves back into room 1. And then room 2. But that doesn't seem right. And there might be a bug. But we'll have to look at that. That seems to be, to me, like a bug. And I don't want to debug this right now, but we should be able to write, this is the case where we'd want to write a model, because user A dropped key in the second room, and I don't see a user B moving to the second room. There's only 2 moves and they're both user A. So that to me is definitely a bug, and that'd be something that'd be nice to take a look at as to how that occurred. But hopefully you get a sense of, like, that's really nice that the world is like the commands that we're generating can drive the actual thing. Here we have a simpler bug where we're going to break broken lock door. So broken lock door doesn't change the lock state. And this one tests that we run a quick check and we want to know that the smallest thing didn't pass and that actually the smallest command is take key unlock door lock door, right? So for any possible universes, that's the shortest command sequence. Somebody has to take possession of the key, unlock the door, and then lock the door, and then at that moment we have an inconsistent state, right? There isn't a smaller set of steps for that. And then I think we just run tests, right? So that's nice, and that one includes this broken EQ model test, right? So we're able to detect that we always get this if we forget to change the lock state. And then, and when I have more time, we can look into as to why somebody can pick up the key when they're in the wrong room. And in fact, if there was more time, it would be great to take this and simply check for a property-based test verifying that it's not possible to pick up the key if you're not in the room the key is in. I will point out that there are, of course, two possibilities. It could be that the game is broken or that we messed up the model. And that is definitely something to take into consideration, that you have to build confidence that your model is correct. And then by interacting with the real system, you can get a sense of, oh, there's something wrong with the model or there's something wrong with your actual application. That is definitely something we encountered, that there is some work to get to the point where you believe your model does correctly model the system, and whether the bug that you're seeing is a bug in the model or in the system under test. I think that's all I have for that part. I'm going to switch back to the slides. Should you use this? I honestly don't know. We at Vouch, it was super useful for the work that we were doing. Again, we hit numerous cases where we broke the chain, and until we had this, it was very hard to be confident that we weren't going to break the chain. So again, I feel like if you have properties that are of that nature, where you just absolutely want to know that some code change doesn't affect some global property of your system, I think it could be useful. Also, the other idea behind Fugato that you could probably see is that, when you want to model multiple actors with sort of complicated states and complicated actions, like even though that world is tiny, it should be clear that there are a complex set of rules about when things can or can't occur. And, you might be building an app where that's true, where you do have this complex relationship between two users and these conditions in the same way that that little game had. Then again, this might be useful. And also, if you just want to learn how test check works, I mean, again, I personally was not that familiar with test check, and most of my understanding of test check came from, working with, especially on the generator side, building these arc generators. I found it really useful for that. And then, of course, if you like building like little games, I actually think it's something like this could be really neat if you're building some sort of like multi-user dungeon game. Is it double the work? And I would say, in some sense, it is true. It's just a question of whether that work is valuable to you. I think it's a big trade-off, right? That you have your system, and then in order to test it in this way, you're going to have to build a model of the portion of the system that you want to test. So I would say that this is not a small amount of effort, but I think the payoff is kind of like a big payoff, and it's just a question of whether in your particular situation that payoff is important. Again, for us, it was that value was just huge. Other things that we're not going to get into, but like I recommend checking out Alan Rano's talk with Test Contract. where he talks about differential testing. They actually, he and the company that they work at, they actually use this to actually cut, like basically, actually build sufficient mocks for all external endpoints. And they're able to basically, when they run the stateful based checking testing, I mean, it's almost like running. It's almost like running the whole thing, right? The confidence goes up way higher. It's like seeing the actual thing run, because not only did they do what I demonstrated, but for any external calls, they came up with a system where those were mocked with enough fidelity. Like for example, you would mock up S3, and then you build a model. You build a model of S3, and then you build a mock that actually responds the way that S3 would respond for putting objects and deleting objects. And then you could run this sort of generative stateful-based property-based testing and get really nice confidence that your system is working correctly. Because again, you built a model of S3, and then you can do both, right? You can actually run, for example, differential testing. You could run the model, you could run your real thing, and then you can check whether the state is the same, right? Whether the actual state is the same between your model and your actual system. And we actually did that at Vouch. When we're actually checking whether the model and the system is correct, we extract out the model state, which is a little bit different from the actual system state, and we say, do they look equivalent? Okay. So I didn't have time to talk about differential testing. There is literature out there about that. Again, I recommend checking out Test Contract. Test Contract definitely has quite a few more features, integration points, which again, you might find extremely useful. Great talk at the last conj. And it supports shrinking and everything else. And I think that's all I have. Hopefully I've not gone too long.